The potential impact of a solar storm on Earth is significant and covers a variety of critical areas of modern life. Here are some of the main impacts a solar storm could have. Disruption of power systems. A solar storm could cause damage to electrical systems and power grids, resulting in widespread blackouts. This would affect not only homes, but also critical infrastructure such as hospitals, communication centers, and water and sanitation facilities. Damage to communications. Solar radiation emissions during a storm can interfere with radio, television, telephone, and internet communications. This could harm the ability to coordinate emergency responses and communications between individuals and organizations. Impact on technology. Sensitive electronic equipment such as computers, GPS navigation devices, and satellites can be damaged by intense radiation during a solar storm. This could lead to failures in critical navigation, communication, and positioning systems, with significant consequences for transportation, logistics, and security. Human health risks. Astronauts in orbit may be particularly exposed to solar radiation during a storm, which could increase the risk of radiation-related illnesses. Furthermore, the stress resulting from widespread disruption to essential infrastructure and services could have impacts on people's mental and emotional health. Economic challenges. Damage caused by the solar storm could have a significant impact on the global economy, resulting in financial losses due to the disruption of business operations, damage to infrastructure, and costs associated with recovery and reconstruction. Solar storms are natural phenomena that occur when the sun releases a significant amount of energy and charged particles into space, including towards Earth. These events are caused by disturbances in the solar atmosphere, especially in active regions of the sun, such as sunspots and solar flares. Solar storms are influenced by the solar cycle, which is an approximately 11-year cycle during which solar activity varies. The solar cycle is characterized by periods of increasing and decreasing solar activity, including the number of sunspots and the occurrence of solar flares. Sunspots are darker, cooler areas on the sun's surface caused by intense magnetic activity. These regions can be sources of solar storms as they are associated with disturbances in the solar atmosphere, such as solar flares and coronal mass ejections. Solar flares are sudden explosions of energy in the solar atmosphere, resulting in the release of radiation and charged particles into space. These flares can vary in size and intensity, and larger ones can trigger significant solar storms. Coronal mass ejections are events in which the sun releases large amounts of magnetically charged material into space. These ejections can accompany solar flares and are an important source of solar storms. When a CME hits Earth, it can disrupt the planet's magnetic field and trigger auroras, as well as interfere with communications and electronic systems. When charged particles from a solar storm reach Earth's atmosphere, they interact with the planet's magnetic field, causing auroras at high latitudes. However, if the storm is strong enough, it can disrupt communication systems, electrical grids, and electronic equipment, posing risks to critical infrastructure and modern technologies. The long-term consequences of a solar storm can be significant and far-reaching, affecting multiple aspects of modern life and global infrastructure. A solar storm can cause significant damage to electrical power and communication systems. Electronic equipment, transformers, and power transmission lines can be damaged by intense electromagnetic radiation. This could result in prolonged blackouts and disruptions to communications networks, taking weeks or months to fully restore. Sensitive technologies such as communication satellites, GPS navigation systems, and telecommunications networks can be damaged or rendered useless during a severe solar storm. This could negatively affect a wide range of sectors, including transport, logistics, finance, and emergency services. In addition to damage to infrastructure, a severe solar storm can also have public health impacts. Prolonged outages to power systems can affect the availability of essential medical services, while disruption to communications can make it difficult to coordinate emergency responses and disseminate vital information to the public. The costs associated with recovery and rebuilding after a significant solar storm can be enormous. In addition to the direct costs of repairing and replacing damaged equipment, there may also be economic losses due to disruption of business operations, delays in the production and distribution of goods and services, and impacts to global supply chains. A severe solar storm could expose vulnerabilities in critical infrastructure and technological systems, highlighting the need for additional mitigation and preparedness measures. This could include investing in more resilient technologies, developing contingency plans, and international cooperation to address solar threats. To mitigate the potential impacts of a severe solar storm, it is critical to implement preparedness and precautionary measures. Establish robust solar monitoring systems to detect anomalous solar activities such as solar flares and coronal mass ejections, CMEs. This allows authorities to issue early warnings about the imminent arrival of a solar storm, allowing enough time for adequate preparations. Develop detailed contingency plans for different sectors, including energy, communications, healthcare, and critical infrastructure. These plans should address emergency response procedures, resource allocation, coordination of efforts, and communication with the public. Strengthen the resilience of critical infrastructure, such as electrical power grids and communication systems, to withstand the effects of a solar storm. This may involve installing surge protections, reinforcing transmission lines, and investing in more robust and redundant technologies. Maintain adequate stocks of emergency supplies, including non-perishable food, drinking water, medicines, first aid equipment, and other essential items. This helps ensure the ability to meet the population's basic needs during a prolonged crisis. Take steps to protect sensitive electronic equipment, such as disconnecting devices from the electrical grid during a solar storm, using surge protectors, and installing backup power systems such as solar generators or batteries. Educate the public about the risks associated with solar storms and provide clear guidance on how to prepare for and respond to these events. This includes information about what to do during a solar storm, how to stay safe, and how to access help resources and information. Promote cooperation and information exchange between countries to collaboratively address solar threats. This could include sharing solar monitoring data, developing common safety standards, and coordinating response efforts at a global level. Speculation about catastrophic outcomes related to severe solar storms can be unsettling, but they are important for understanding the potential extreme impacts of these events. A severe solar storm could result in the complete collapse of electrical and communications networks on a global scale. This would lead to widespread blackouts, rendering communication, transportation, health, and public safety systems inoperable. The lack of electricity and communication could cause widespread chaos and panic, with serious consequences for society. Solar flares and coronal mass ejections can cause irreparable damage to critical infrastructure, such as electrical grids, transportation systems, and water and sanitation facilities. This could take years, or even decades, to fully repair, resulting in prolonged disruptions to daily life and the economy. A severe solar storm could have devastating impacts on public health. Disruptions to health services due to lack of electricity and communication could lead to an increase in preventable deaths and illnesses. Additionally, exposure to solar radiation during a solar storm can pose significant health risks, including cancer and other radiation-related illnesses. The collapse of energy and communications networks on a global scale could trigger geopolitical instability and conflicts between nations. Competition for scarce resources such as food, water, and energy could lead to rising tensions and even armed conflicts. Furthermore, the inability to coordinate emergency responses and humanitarian assistance could lead to large-scale humanitarian crises. A severe solar storm could have significant environmental impacts, including damage to the ozone layer and increased ultraviolet radiation at the Earth's surface. This could affect the health of plants, animals, and ecosystems, leading to irreversible changes in biodiversity and natural cycles. Therefore, given the possible catastrophic impacts of solar storms, it is crucial to invest in preparation, monitoring, and international cooperation. Only in this way can we minimize the risks and protect our infrastructure and society against the adverse effects of these solar events.